Recall that the definition of acceleration is that it is velocity over time, or maybe more appropriately stated as change in velocity over time. A thing to remember though is velocity is a vector. So I've stated here again as a formula the definition of acceleration where a vector is equal to delta v vector over delta t. Velocity being a vector though includes direction. So what that means is when something is moving in a circle, it's going to involve acceleration. So in that sense, I think these first two statements kind of imply this last statement here about motion in a circle involving acceleration. Specifically, the kind of acceleration is called centripetal acceleration. The word centripetal means towards the center, and we will find out that that has something to do with the direction of the centripetal acceleration. So in this topic, we're going to explore some of the details of this, where this formula comes from, how to interpret it, what it means, how to use it. It turns out if you said, well, are we going to tell the whole story of how we get here, starting from like these basic concepts and this basic definition of acceleration? I'm going to try to tell most of it, but it turns out to really do it correctly, you would need calculus. So I'm going to have to maybe kind of dance over a few steps in a way that doesn't involve actually having to use calculus. I just want to make everyone aware of that fact, but it'll give us some bigger context for how to use this formula and one. In the meantime, I kind of want to throw out maybe an optional assignment here as I'm doing this video. This is an assignment I've given to classes for years. As I've said, to help understand the context of this formula, if you're ever driving a car, or maybe even better if somebody else is driving a car, and you go through like a bend in the road, maybe a particularly steep bend in the road, I've always said, hey, think of this formula every time this happens. Think like, you know what? I'm experiencing v squared over r right now. And I think that will help you to kind of understand and kind of bring into your mind the context of like this formula, what it describes, and when it might be useful.